Hey everyone, welcome to another video. So in this video, we're going to be revising a little bit about topic 1.5, determining limits using algebraic properties. After we're done doing some of the problems in this worksheet, not all of them, we're gonna go to these 4 limit exercises. So let's get started. Okay. So we're going to cherry pick some of the hardest questions over here. We're going to choose some of them. So we're going to start with number 12. Number 12, it says we need to find limit as x is going to 2 for f of x times g of x. So first things first, let's focus on f of x. At x is going to 2, we notice that at 2 minus the function f is 1 and at 2 plus the function is at minus 1. So it might require us to find both sides of the limit over here. So limit as x is going to 2 minus for f of x times g of x is going to be limit as x is going to 2 minus. So at 2 minus the function f is tending to 1, and for g of x the 2 minus is tending to 0, so 1 times 0 is 0. Similarly, limit as x is going to 2 plus, for f it is going to be negative 1, and for g it is still going to be 0, so 1 times 0 is also a negative 1 times 0 is also 0. That means that the original limit that we are studying is going to tend also to 0 because the limits at both sides are equal. We're going to jump to number 15. In number 15, it says we want to find limit as x tends to negative 1 f of x squared. So the first thing that you must think about is that what happens when I do x squared to the power of 2 at negative 1 minus. That means negative 1 minus is almost equivalent to saying negative 1.001, for example. If you square this number, then the first thing you'll notice is that it will become positive. And it is still going to be a number which is super close to 1 point something. Like it will be equal to 1 plus. So this means that the following limit that we have is equivalent to limit as x is going to 1 plus for f of x. This is how you need to think about algebraic manipulation over here. So limit as x tends to 1 plus for f of x, we're focusing on f of x. 1 plus, it is giving me 0. So we say that limit as x tends to 1 plus for f of x is going to be 0. We're going to move on to question number 18. So first things first, we're going to use the composite method over here. Limit as x is going to 2 plus f of minus f of x. It is going to be f of limit as x is going to 2 plus minus f of x. Now the subtraction sign, you can send it behind the limit, so it will be f of minus limit x of 2 plus f of x, which will be 2 plus for f of x. It means we're studying it over here, which means it is negative 1. So it's going to be f of minus, the minus over here, of minus 1, which is going to be positive 1. So what is f of 1 over here? F of 1, we're going to choose the black dot, which is going to be 2. So as you can see over here, the algebraic manipulation is as easy as you make it, to be honest. You know, like if you are really good with algebraic manipulation, you just be confident with your answers and you're going to get it right. So we're going to jump into the questions that I have over here. So here's the thing. Over here in the first question, we notice that limit of x is going to 0 0 is a number that will cause the function to be undefined, because if you replace 0 instead of the x, the denominator is going to be ending up being 0 as well. So you're going to have an undefined form. However, if you are able to simplify the function and you get rid of this discontinuity, then you're good to go. You don't need to find two-sided limits anymore. So the first thing that we notice over here is that the fact that we can take x as a common factor up and down. So limit as x tends to 0, x as a common factor will leave me with x squared plus 4 over x as a common factor, which would leave me with x plus 13. So as you can see, I got rid of my problem, which is the x over here. So now simply you just substitute x with 0 because there's nothing wrong with the remaining function that you have over here. So it will be 0 plus 4 over 0 plus 13, which will be 4 over 13. That's it. Now the second one is a problem, because over here, if you're going to replace -3 instead of the x, then the absolute value has a denominator of 0, so you're going to get loads of problems. And it's not an easy way to simplify over here and just be like, let me cross these two and the answer is going to be 1. An absolute value always is a positive value. So this means you have to remind yourself of something, that the absolute value of x plus 3 is x plus 3 itself if x plus 3 is positive. However, if x plus 3 is not positive, then the absolute value is going to be minus x plus 3 if x plus 3 is negative. So if it is negative, if this value over here is naturally negative, we have to plant the negative sign behind it, because now negative times negative is going to end up being positive, which applies for an absolute value, because an absolute value is always positive. So now, if we are studying it from both sides, so limit as x is going to -3 minus for x plus 3 over absolute value of x plus 3. -3 minus is bigger than 3. So let's focus on the denominator over here. -3 minus is bigger than 3. So the outcome of the absolute value, I know it is going to be negative. So in order to change it into a positive, I must apply the second rule. So it is going to be limit as x is going to -3 minus x plus 3 over minus x plus 3. Now I can simplify, and the answer would be -1. Now similarly, if I have limit as x tends to -3 plus, I know for sure that -3 plus is smaller than 3, because -3 plus is -2.99999, and that is smaller than 3. So now I know that the absolute value of x plus 3 is going to be a positive value. So now I need to apply the first rule. So now it's going to be x plus 3 over x plus 3. And now, according to the simplification, you're going to have +1. Now, since -1 is not the same as +1, that means that this limit does not exist. Moving on, we have limit as x tends to -2 for the following function over here. This is just simple factorization. If you factorize the top function using factoring method, you're going to get x plus 2, x plus 4 over, of course you can use a calculator to find the factors themselves. X squared minus 4 is basically a squared minus b squared, a remarkable identity, which is going to give you x minus 2, x plus 2. We forgot to write the limit over here. X is going to -2. So now we can just cross x plus 2 with x plus 2. I got rid of my problem and just replace x with -2. So -2, +4 over -2, -2. Notice that when I reach the substitution phase, which is over here, I stop writing the limit symbol or the limit process over here, because you don't need to write it whenever you're substituting. However, every single step before substituting, you have to write the limit symbol. It's important, and yeah, it will be graded. So -2, +4 is going to be 2, and -2, -2 is going to be -4, which is going to be -1/2. We come to our final question. Sine square 4x over 4x squared as x is going to 0. It's a very easy question, but you need one rule to solve, and that is every single time, only when x is going to 0, then sine x can be considered as x. Okay? So only when x is going to 0, only then you can consider sine x as x. So this means sine 4x can be considered as 4x, which means that sine squared 4x can be considered as 4x squared. So now we can change our function into limit as x is going to 0 for 4x squared over 4x squared, which is going to be 16x squared over 4x squared. We can cross out the x squared, and 16 over 4 is going to be 4. I hope you guys understand. Leave a like, leave a comment if you have any questions, and thank you for watching.